The basic objective of golf is to get the golf ball into the hole in as few strokes as possible. There are 18 holes on a typical golf course.
To get the ball to move in the desired direction at the desired speed, a golf club is used to hit the ball.
A variety of golf clubs are used during the game, such as drivers, used for long distances, irons, used for medium distances, and putters, used for short distances, plus many more.
The holes vary in difficulty based on how far away they are from the starting point and what obstacles are in the way.
Although you may not realize that the sport of golf actually incorporates many physics concepts such as impulse, conservation of momentum, and projectile motion. So how does a pro like Tiger Woods get the ball to go so far? Well, one of the techniques used in golf is to always follow through on your swing. Although you may not realize that this is directly related to physics. You follow through on your swing so you can increase your impulse time, which will give the ball more momentum. Impulse is the contact part of collision and is the only way momentum can be transferred. By following through, you maximize the amount of time the club spends in contact with the ball. The formula for impulse is impulse equals force change in time equals mass times change in velocity equals change in momentum. For example, if a golfer hits a golf ball with a force of 8,000 newtons and the contact time is 0.004 seconds, he will have an impulse of 32 newtons times seconds. However, if a golfer follows through and increases his impulse time to 0.005 seconds, his impulse will increase to 40 newtons times seconds. A greater impulse means a greater momentum.
Did you know a golf ball is actually a projectile launched at an angle? A projectile is an object with independent vertical and horizontal motions that moves through air only under the influence of gravity after an initial launch. By setting up a Vivada chart, one can figure out, using the kinematics formulas, the acceleration, time, distance, and initial and final velocity of a golf ball. For example, if a golf ball is hit with an initial velocity of 35 meters per second at an angle of 45 degrees, we use the formulas initial velocity equals initial velocity times cosine theta and initial velocity equals initial velocity times sine theta to find the initial velocity of the x component and y component respectively. Then we can use these numbers to fill in our chart. The initial velocity in the x and y direction ends up being 24.7 meters per second. In every projectile problem, the acceleration in the x direction is 0 meters per second squared, and the acceleration in the y direction is negative 9.8 meters per second squared, the acceleration due to gravity. Therefore, the final velocity in the x direction is the same as the initial, 24.7 meters per second, and the final velocity in the y direction is 0 meters per second, because at its maximum height, the ball will be traveling at 0 meters per second. Then we figured out the distance and time in the x and y directions by using the kinematics formulas. We used the formula final velocity equals initial velocity plus acceleration times time to find the time in the y direction, 2.52 seconds. We multiplied this by 2 to find the time in the x direction, 5.04 seconds. Because the time in the y direction is only equal to the time the projectile takes to reach its maximum height, not the time it takes to land again. Finally, we figured out the distance in the x direction by using the equation distance equals initial velocity times time plus 1/2 acceleration times time squared. The distance ends up being 124.5 meters. To find the maximum height in the y direction, we use the formula final velocity squared equals initial velocity squared plus 2 times acceleration times distance, which ends up being 31.13 meters. By setting up our Vivada chart, we figured out the initial velocity, final velocity, acceleration, distance, and time in the x and y components of our golf ball projectile. The ideal angle for the projectile is 45 degrees because at this angle, the golf ball has the largest range and can travel the farthest distance.
Swing, swing from the tables of my heart.
Momentum is a measure of the motion of an object. The conservation of momentum states that the combined or added momentum of all objects before a collision is equal to the combined momentum after a collision. In golf, the collision between the club and golf ball is an elastic collision. During an elastic collision, there is the same number of independently moving objects before and after the collision. In order to prove that momentum is conserved and figure out the velocity of the golf ball after the collision, we must first find the added momentum of all parts before the collision. We use the formula momentum equals mass times velocity to do this. For example, if a golfer with a golf club has a combined mass of 75 kilograms and swings his club at 2 meters per second, we can calculate his momentum to be 150 kilograms times meters per second. The golf ball, which is 0.045 kilograms, has a momentum before the collision of 0, since it is at rest. After the collision takes place, the golf club transfers some of its momentum into the golf ball. If after the collision, the velocity of the club reduces to 1.98 meters per second, its new momentum is 148.5 kilograms times meters per second. Therefore, to get the momentum of the golf ball, we subtracted the momentum of the golf club after from the total, and got the momentum of the golf ball to be 1.5 kilograms times meters per second. Now we can figure out the velocity of the golf ball by using the formula momentum equals mass times velocity. The velocity ended up being 33.3 meters per second.
Even the equipment used in golf is designed according to physics. For example, the dimples on a golf ball are designed to increase lift. If a golfer hits a dimpled ball with backspin, the dimples at the bottom of the ball scoop up the air and slow it down, whereas the dimples on the top scoop up the air and speed it up. This increases the difference by which the air travels around the ball. When the air is traveling slower under the golf ball and faster above it, an upward pressure forms. This is lift. Increasing lift allows the golf ball to travel farther. Everyone can enjoy golf. Big, medium, and small.